When you rub your palms together fast, you'll notice that they get heated up. And we actually do this to get warm when we're feeling cold. This is because of friction. And the faster you rub your palms, the hotter they get. Basically, the higher the relative linear speed between your palms, the higher the heat generation. The same phenomenon occurs during metal cutting. The temperature rises as the cutting speed rises. The tool material is designed to work at a certain temperature range. Below this range, you are underutilizing the tool and the cycle time will be unnecessarily high. Above this range, the tool wear will be too high and you end up with high tool costs and high machine downtime to keep replacing the tool. High cutting speeds and temperature also result in poor surface finish and unwanted metallurgical changes in the workpiece. Cutting speed depends on the RPM and the diameter at which you're cutting. If you're cutting at constant RPM, as you cut at various diameters, the cutting speed fluctuates. So sometimes you're cutting below optimum speeds and sometimes at above optimum speeds that result in high tool wear and poor workpiece quality. This is why it is preferable to cut at constant surface speed, also called constant cutting speed or CSS. This is how CSS works in facing. You can see that as the tool moves towards the axis, as the diameter reduces, the spindle RPM rises so that the cutting speed is constant. Here is the same animation in slow motion. This video shows constant surface speed on the machine. You can see and hear the RPM increasing as the tool moves towards the axis each time. The machine changes the RPM automatically according to the diameter based on a command in the CNC program.